Hi, my name is John Craig, and this is my midterm individual presentation. My major achievements for these two sprints are I implemented the targeting of specific applications from receive voice command. I implemented module registration and an API endpoint to retrieve a list of the currently registered modules. I implemented logging of messages through the dispatcher and an API endpoint to view the current log. For my first story, as a user, I want to register my module with the dispatcher so that I can ensure it receives the commands it needs to receive. In our proof of concept, the application and its various modules act as a hub network, with the dispatcher module being the central hub. To implement module registration, I created hash maps to currently connected WebSocket sessions to sessions that have registered. To register a module, they connect to the WebSocket at the specified port and send a message following our API format, which is caught at our dispatcher module, and the connection is then mapped to a registered session object. For error handling and security, I also implemented a threaded timer to disconnect any session that fails to identify itself as a registered session within the allotted time. My next story is, as a user, I want to see a list of modules that are currently connected to the system so I can choose which ones to manage. For the list of connected modules, I created an API endpoint where users can view an output module list at the specified URL. This endpoint is implemented using the Spark Java framework. The endpoint acts as an HTTP GET for the specified data, namely the names of all the registered sessions that are currently attached. This endpoint has also been integrated into an output display in the dashboard module of our project by our dashboard team. For my next story, as a user, I want to see a well-formatted list of messages that have been through the network so I can understand how modules are interacting. The dispatcher module, as stated before, acts as the hub in a hub network topology, and as such, the communication traffic from the other modules have to pass through the dispatcher on their way to the target. All of our message payloads are sent as JSON objects at OSI level 7, so to construct a log, I catch all the incoming messages, scan them for the relevant information, such as the sender, recipient, command, or message, and the timestamp, etc. Additionally, I similarly collect all outbound messages originating from the dispatcher module itself and its internal logging information. I store all of these entries in a JSON array ordered by timestamp, and I discard the oldest log entry to make room for the new one once we've reached a certain capacity so as to not waste memory. After I have this array constructed, I take it and I pass it to another API endpoint, and the log messages are displayed in order of timestamp. At the time of this video, we've also integrated this into our dashboard module as well, so there is output in our dashboard as well as the API endpoint URL. For my next story, as a user, I want to use an activation word the system recognizes that indicates I intend to select a new application to direct commands so that I can easily switch my focus. Currently, our activation word is target, so the system looks for that. For this story, my implementation is based around the observer pattern. The routing machine parses messages sent to the dispatcher intended for routing to a module target and identifies if they contain the defined targeting switching keyword, which is currently target but can be changed to anything the user would like. I accomplish this by tokenizing the incoming message using a sequence of buffers to identify the target keyword. So basically, in saying this, when a command comes in, I tokenize the string that's within the JSON, and I look for the targeting keyword. And basically, I'm deconstructing the command as it comes through to tokenize and parse it, and then I reconstruct the command as it goes back out. Once it's identified the targeting keyword, a flag is thrown so that the next token needs to be checked against our map of registered session names. And here is an example of the observer pattern and a UML diagram of our implementation, or my implementation rather. And finally, as a user, I want to name an application after my activation word is selected as the target of my commands so that I can command specific applications. This story became integrated with the observer pattern shown here in the last during implementation and planning, as I just decided that it needed to be integrated because they were closely related. Once the targeting keyword is found, the next token is checked against the map of registered session objects. Should that token be a valid registered session, the target is changed to that registered session, the listeners are notified, and the current message is stripped of the targeting keyword and name and sent on, and then future messages will be routed to that selected target. In the case where the token after the target keyword is not a valid registered session, then the message is assumed to be for the current target. Like perhaps the module needs the word target for some function in its own functionality. So the message is reconstructed with that target keyword and sent to the current target that is currently active unaltered. Conclusion. I have implemented some of the critical subcomponents of our dispatcher module, which is providing the integral routing networking features of our team's design. Routing target selection is a feature our project hinges upon and utilizes rudimentary parsing of strings as well as input validation. Session registration allows modules to be targeted for commands, and the corresponding API endpoint allows the user and other modules to understand what modules they can currently command. Logging enables the user to track network state and identify problems in module communication or commands. Thank you.